Children, I hope class 10 children are watching this video. So this is Bhagwan Academy's first initiative that we have started making videos, especially for maths. And very soon we will try to upload many contents, video contents in YouTube. You might be watching on YouTube. So our first topic is real numbers. You might be having books, many of you might not be having books, so not to worry, already many contents have been sent on WhatsApp. And if you don't have, even on WhatsApp also till now, not to worry, whatever things we are going to discuss on videos, just you watch properly and whatever things will be given, just you try to solve. But one request would be there always, whenever you are watching video, just be with your pen and pencil and copy. And if you have book as well, so that easily you will be able to understand, and together you try to solve all the questions. So here you see our first topic, we have real numbers, and on this real numbers we are going to learn what is real number and Euclid's division lemma. This is not your topic, already you have learned in class 9th. So just we start. Here you see, we have real numbers, already it has been written, you see. In class 9 we studied about real numbers. So very briefly I am telling you what is real number. Real number includes all the numbers till now you have learned, that you remember. So you have learned natural number, and what is natural number? Counting numbers are called natural numbers. Counting numbers are what? 1, 2, 3, 4 up to infinity. So this is called counting number or natural number. If you are including 0 with counting number, so if you are starting 0, 1, 2, 3, 4 up to infinity, this is called whole number. And what are integers? Integers are positive counting number, negative counting number, including 0. It means what? Natural number, whole number, or whole number and negative integers or negative counting numbers. These all are called integers. Then you have learned in your previous class rational numbers and irrational numbers. What are rational numbers? Rational numbers are the numbers which can be represented in the form of p by q, where p and q are integers and q is not equal to 0. So these all the things already you have learned. And if you have doubt, just if you have a class 9 book, just again you go through properly. First chapter you have number system. So just you go through properly, I think everything will be recalled. Okay, so next you have, in this, especially in class 10th, what you have? Euclid's division lemma. And this is also not a very big thing that you will not know, you will not understand. It is very easy things it is. Euclid's division lemma. So before that lemma we have, what is lemma, just you see. A lemma is a proven statement used for proving another statement. Lemma is what? It is a proven statement. A lemma is a proven statement and used for proving another statement. This is called lemma. So first we have Euclid's lemma, and don't be confused or get afraid by saying this word Euclid's division lemma, because this is not a very new thing, already you have learned before. Here you see what it says. For any two given positive integers, A and B, if you have any positive integers A and B, there exists unique whole numbers Q and R such that A is equal to BQ plus R, where R is greater than or equal to 0 and less than B. So by seeing this definition, it seems that very new things and very amazing, unexpected things you are going to learn. This is not unexpected thing or things which you have not seen. These already you have done in your previous classes, but only language has been changed. Here you see, already in previous classes we have done division. So in division what we were doing? Suppose any number you have, 117 and you need to divide by 14. So what we used to do, if by 14 you are dividing 117, 14 8 ja 112. If you are subtracting this, you are getting 5. So this was called divisor. This was called dividend. Already you have learned. This is called quotient and this is called remainder. So what we had, dividend is equal to divisor into quotient and plus remainder. The same thing it is here. Dividend is equal to divisor into quotient plus remainder. And the same thing division lemma says in its own language. Here you see what it says. If you have two integers, suppose 117 and 14. Two integers you have 117 and 14. One integer is bigger than the other. So suppose in place of A you have 17. In place of A you have 17. And in place of B you have 14. If you are dividing 117 by 14, what you are getting? 8 as a quotient. It means in place of Q you are getting 8, and in place of R, this R, what you are getting? That is 5. R is equal to 5 you are getting. Now you see, whenever you divide, one thing you might have observed. If remainder what it is coming, always it will be lesser than 14. It means always 5 will be lesser than 14. So it will be lesser than, here it has been written R is always lesser than B. It means 5, or whatever remainder you are getting, here also 5 you have got. So 5 is lesser than 14. In other division also, properly if you are dividing, and if remainder you are getting, always this remainder will be lesser than divisor. And one more thing is that always this remainder what you will get, either 0 you will get, it means no remainder, or if you will get, that will be greater than 0. So remainder what you are getting, either that will be 0 or greater than 0. So the same thing has been explained by this Euclid division lemma. For any two given positive integers A and B, suppose any two integers you have A and B, and then just unique whole numbers, if these two numbers can be expressed in this way, so that A is equal to BQ plus R, and R is greater than or equal to 0 or lesser than B. So by seeing this example, just you try to observe yourself. It will be very easy. Just you see this division and just you assume, place the digits in place of A, B, Q and R, and just you observe, you will get this Euclid's division lemma very easy. You will understand properly. So this Euclid's division lemma is very useful and its applications are there. So we will discuss on application. But before application, few things I would try to make you understand. So those things are, just you see, here you see, any number if you have, suppose just you see 1, 2, 3, 4 up to 10, then 11, 12, 20 and up to 100, even more numbers you have. So these numbers can be expressed in very different way. Suppose if it is asked to you that this number you express in the form of multiples of 2. So how will you express? Multiples of 2, it means what? If it is say multiples of 2, it means this 2 you are getting, then again 4 you are getting, next you are getting 6, then you are getting 8 and 10 and so on. So it means what? Multiples of 2 can be expressed as 2m, or whole number, if it is asked that this all the numbers what you are saying, how can you express in the form of multiples of 2? So multiples of 2 we have expressed, we have got 2, 4, 6, 8, 10 and so on. 1, 3, 5, 7, 8, 9, how it can be expressed? We can express this in the form of 2m plus 1. It means what? Either these numbers will be 2m, it means multiples of 2, or 2m plus 1 means 3. 2m plus 1 will come 3 or 5 or 7 or 9 or 11 or 13 or 15 and so on. It means these numbers have been expressed in the form of multiples of 2 in this way, 2m and 2m plus 1. The same thing if you are going to express in the form of multiples of 3, how will you explain? Here you see. Here you see, if you are expressing the same number in multiples of 3, so multiples of 3 would be 3, 6, 9, 12, 15, 18, 21 and so on. It means either this can be expressed in the form of 3m and what you are getting? Next number how will you get? 3m plus 1. 3m plus 1. Next what you will get? 3m plus 2. So this whole number, all number can be expressed in the form of either 3m or 3m plus 1 and 3m plus 2. So 3m plus 1, 3m plus 2 if we are saying, it means these all numbers are being taken together. In the same way, if you are taking 4 in the form of multiples of 4, if you are taking your numbers, then the same thing is there. First number will be 4, second number 8, third number 12, fourth number 16 and so on will come. So if you are expressing these numbers in the form of multiples of 4, it will be 4m or 4m plus 1, it means this number. 4m plus 2, it means next number. 4m plus 3, it means 7 and 8 is already will come in 4m. So these all numbers can be expressed in this form also. In the same way, with 5 also it can be done, multiples of 5. So what it will come? 5, 10, 15, 20, 25, 30 and other numbers 35, 40. So this can be expressed as 5m plus 1, it means this number. 5m plus 2, it means this number. 5m plus 3, it means this number. And 5m plus 4, it means this number. So these all the numbers can be expressed in the form of multiples of 5 in this way. 5m and 5m plus 1, 5m plus 2, 5m plus 3 and 5m plus 4. So this m what I have written, that can be written either any alphabet can be taken, either q you take or n you take, whatever. This can be written as 5q also, whatever you feel good, that can be written in that form. So why I am saying these all? Because when you start your Euclid's lemma, applications, all the things are going to come. So by that time, just you recall this, you will understand. So in next video, we will start applications and we will start solving our problems also. So till that, thank you.